Okay, college algebra. This is topic 3.4. Find the domains of rational functions. Okay, here's a rational function. It's rational because of that big fraction bar right there. And whenever we have rational functions, we take whatever equation that's in the denominator and we write it separately. So we'll have 9 minus x squared. And then we set this not equal to 0. That's because it's in the denominator. Now, because it's in the root, the rule for that is taking the 9 minus x squared and setting it greater than or equal to 0 to find the domain. Now, when we combine these, this one says do not use equal sign. This says greater than or equal. When we combine these, we actually have 9 minus x squared simply greater than 0. So this is the entity that we'll use right here, and we'll solve this. Now, right now, greater than 0 means we're looking for positive parts. I'm going to, I want this to be the x to lead, so I'm going to say x negative x squared positive 9 greater than 0. And then I'm going to multiply everything through by negative so I can get an x squared here. So multiply everything by negative 1, we get positive x squared minus 9. And this greater than sign changes to negative to less than 0. Now we're looking for this equation being less than 0, which means negative parts. Okay, now let's begin from here. So x squared minus 9, we're going to separate that here, x squared minus 9. Since there's no equal sign, we'll say this is not equal to 0. So we're temporarily taking off the less than sign just to solve it. So this will factor into two pieces, not equal to 0, x plus 3, x minus 3. Okay, then we're going to solve these individually. X plus 3 not equal to 0, and x minus 3 not equal to 0. And subtracting 3 from both sides, we get x does not equal negative 3. Add 3 to both sides here, we get x does not equal positive 3. Now what do we do with these two answers here? We put them on a number line, negative 3 and 3. And because it says it does not equal, we're going to use open circles here and here. So that's how we use the do not equals. Now, how do we use the idea that this is going to be negative? Well, we want to find out which of these three areas will be a negative area. So I'm going to test these three areas out by using, let's say, negative 10. X is negative 10. So let's take negative 10 back up to the original. Negative 10 squared is 100, and 100 take away 9 is going to be a positive number. Okay, it's about a 91, so that area would be positive. Then let's say x equals 0. If x is 0, we go back up to this one right here. 0 squared is 0, take away 9, which is negative 9, which is all negative. So this area will be negative. And finally, this area here, let's test this with a 10 after 3. So if x is 10, 10 squared is 100, take away 9 is about 91, so that area will be a positive area. And since we're looking for negative areas right here, this is the only section that we can use. So that section is from parentheses negative 3 to 3, and this is the domain written in interval notation.